Hello everyone, today we're going to look at usaco-training healthy Holsteins. In this problem we're given V types of vitamins, and for each of those we're given that a cow must eat at least X vitamins for each of those V types. And then we're given G, which is the types of feeds that are available. Okay, and for each of those types we have V integers, which means that it has like a specific amount of each type of vitamin for each type of feed. So for this example, given that there's 4 vitamins or 4 types of vitamins, and the requirement for vitamin class number 1 is 100, for the second one it's 200, for the third one it's 300, and for the fourth one it's 400. And we're given 3 types of feeds, which correspond here, where each line corresponds to the type of feed, and then each column corresponds to the type of vitamin. Okay, so we're supposed to print the minimum number of scoops a cow must eat. And then we're supposed to print the sorted list of the feed types a cow is given. So for this example, it would be the most optimal solution would to be picking feed type 1 and feed type 3. For example, for the first vitamin, you can just take the 900 from the third type. For 200, you can take 50 and 150. For 300, you can take 389. And for 400, you can take 50 plus 399. Okay. So let's just write it out. So I'm just going to rewrite the sample input. So you have 400, 200, 300, and 400. And then we're given 3 number of types: 50, 50, 50, 50, 200, 300, 200, 300, 900, 150, 389, and 399. Okay, so this is our V, and this is our G. So notice that for our constraints, our G is in the range from 1 to 15. And since we're supposed to print the minimum number of like feeds to make it like sufficient, we can generate like all possible like combinations of these feed types. So for example, for the first feed, let's label this 1, 2, and 3. First feed, we can either, let's just say, if we take it or we don't take it. Second feed, we also have a choice to take it or don't take it. Third feed, we also have as well. So for example, one possible solution would one possible combination would to be let's just say to take all 3 of these. So then the bit stream would be represented as 111. So now you need to check if this would satisfy the minimum number of vitamin requirements. So then you could sum up all the values. So for example, for feed type 1, it would be 50 plus 200 plus 900, which would be let's use this 1150. And you would sum all these 3 values up, since all these are counting, or all these are marked as 1. So then for our second one, again, you would add up everything. So this would be 500. The third column would be 389 plus 200 plus 50, which would be 1 second. So it would be 589 plus 50, which would be 639. For the fifth column, you would have 50 plus 300 plus 399, which would be 749. So then, now we compare these values. Let's actually use a different color. So let's compare these values with the corresponding values in our requirements. So if these values or the sum of these are greater or equal to the minimum requirements, then if all of these are true, then we can basically update our answer. So for an answer, we just need to count number of ones that are like activated or number of ones that have ones in them. Okay, so that's basically it. Oh yeah, and also our total runtime would be 2 to the 15 times 1,000, which would be sufficient in this case. Okay, so this problem is healthy Holsteins. So healthy Holsteins. Okay, let's include the bits. Okay, so we're given V and G. So let's read V. So we need to basically read the requirements. So let's actually call this max V constant int. It would be equal to 1005. So then you would read each of your requirements. So then let's call this int rec. Or let's int r equals it should have a size of max V. So let's read r. So now we need to read G. And then we're basically given a grid, so it should be for int I equals 1. And you should loop through each of those vitamins. Let's call this our V, or let's actually call this our scoop, or S. So S, it should be max G and then max V. So max G should be 16. Actually, let's make this 20 to be safe. So let's just, let's read this. So CNS of IJ. Okay, so now we need to basically generate our combinations. So we can do this like recursively. So let's call DFS of 1, which means that we're going to start checking from point 1 if we're going to use it or not. Okay, so let's call this void DFS. So let's call this int I. And we can also, since at the end we're supposed to keep track of the ones that are like possible, or like the ones that we're going to use. So let's represent this in a vector. So this means that the ones that we're going to use. So then basically if I is equal to G plus 1, which means that we're done calculating. Now basically we need to check, and after this, if it's successful, then we update answer, and then you just return over here. So if not, then we have to consider the first condition. So let's just say if we're not using it, then it would, again, you would just be running DFS of I plus 1. Okay, so now basically we're done running if it's not using. So now we need to run if it's gonna use it. So first we need to like push back our element, push back I, since we know that we're using v type I. So now we just need to DFS it again, and then you just pop the element out. And basically my used is basically just a stack, which means that it's last in first out, or first in last out. So now, okay, so now we just need to check if this is like a valid combination. So basically what we can do, because we need to check for each type, so for int I equals 1, let's call this J. Has to be less than or equal to V. Okay, so let's call our sum, which is the sum of all the like used V. So let's call this int sum. Okay, so now we need to basically, for each, let's call it for each of our used elements, let's call this K. Your sum would be equal to your sum plus the value you have here, which is S of K of J. So now basically if our sum is less than the requirement, then we just don't need to do this because this is like not a valid answer. So we can just return, or yeah, we can just return. So now we know here that this is successful. Okay, so now we have a few cases, or actually now we need to first declare our answer. So let's call this our answer. Originally it should be like pretty big, so it should be let's call this like max v. Actually it should be max g. And let's call this our answer vector. Okay, that's cool. So over here if it's successful. So one case is that if we're using less feeds. So then if use dot size, if it's less than your answer, then you can just update your answer be equal to use dot size. If not, or I mean like now you need to update your answer v. So basically answer v dot pushback, or actually it should be equal to used. Okay, so now basically if these sizes are equal, so if use dot size is less than answer, or actually we don't need to consider this case because we actually generate this in like lexicographically, like first one. Yeah, so actually since we actually want to generate like starting from the top first, so we should check from, we should first do the case if we're gonna use it. So we always get the like lexicographically first one, which is what we want. So we just DFS one. So we just print answer, and then so for each element in your answer vector, you just print x, and then we're supposed to print it. Oh, this should be a space, and then at the end you just print end line. Okay, so let's actually run this. Whoops. Okay, let me fetch the input. Okay, it's still running. 213, which is right. Okay, so let's wait. Actually, we need to we need to read from a file. So free open. This is Holstein.in. We're reading it, and free open the out, and we're writing it to std. So I'm just going to submit it, and the language is C++11. Okay, here we go. Okay, healthy Holsteins. Okay, submit it. Okay, so it looks like we're actually printing like an extra space. So I guess we could do this as well. So we can basically first print the first element of this vector. So let me head over here. So if we print the first element of the vector, we can print answer v of 0. So now for int, let's just use I instead, has to be less than answer v dot length. So then let's actually, so you just print a space, then answer v of I. Okay, guess it's really case sensitive. Here we go. Okay, so Oops, I should have tested it first. So it looks like, let me go here. So length is not, so it should be size, not length. So here we go. Oops. Okay, so I submitted it. So it looks like that is right. So if you have any questions, feel free to leave them in the comment section below. Bye.